So the fact that gold can be hammered into shape, we call that property malleability. So we say the metal is malleable. Gold alloys can be used for teeth. One reason is that they can be hammered into shape. Give another reason. So the other reason we've got here is that gold is unreactive, and that means it won't react with any moisture, any of the food you eat in your mouth. A gold alloy is 78% gold by mass. Calculate the mass of gold in 2 kilograms. So if we have got 2 kilograms, we want to give our answer in grams. Okay, so 2 kilograms, we times that by 78, and then it's over 100 because that's a percent, and that's going to give me an answer of 1.56, but that is still in kilograms because we used 2 kilograms at the start. To finish this off, then we've got to convert to grams. So then we've got 1.56, and we multiply that by 1,000 to get into grams, and that's going to be 1,560 grams. Mark-wise, there's 3 marks in there for this. So if we have done the 78 over 100, we get a mark. We get a mark for this first answer, and we get a mark for converting it into grams. Okay, next one, we've got to link the hazard symbols to the correct definition. So this one here is hazardous to the environment. You've got a fish and a tree in there that are not looking too well. And this one is oxidizing. That means it produces oxygen, which makes them flammable and can feed fires. Carrying on, this is a 6 marker. I'm going to take you through the thinking and the structure that I would do if I was to answer this. So we're told that copper reacts with oxygen to make copper oxide, and the teacher has calculated that if you have 1.2 grams of copper reacting completely, we should get 1.5. So we should form 1.5 grams as an answer. So students has done this with copper pieces, and then they've done it with copper powder, and they've got their results here with some observations as well. So we can see that when they started off with 1.2, neither experiment has made 1.5 as they have found it should. Also, they've made different amounts, with the copper powder making more copper oxide than the copper pieces. Both of them started off red-brown due to the copper, and both of them have turned black because once you've heated it, it forms copper oxide, and copper oxide is a black-coloured chemical. The other thing in here that's worth noting is this first one's been heated for 5 minutes, and the second one has been heated for 10. Okay, so the question says, explain the observations, give reasons why the masses after heating are less than expected. So I've broken this into 3 parts. The first part is explain the observations. Then we need to explain the masses. I've split this into 2 because we've got the pieces, and then we've got the powder as 2 separate things. So first of all, observations. So at the beginning it's red-brown, and that is because copper is a red-brown metal. And then we get this black powder here because copper oxide is a black substance. Then let's look at the difference between the way that the types of copper have reacted. So in both cases, the mass has increased because oxygen is being added to the copper. And because oxygen is being added, oxygen has mass, and that is why the mass is increasing. If we then look at the difference between powder versus the pieces, we can say that the powder, the mass has increased more. That could be because it's been heated for longer, and therefore there's going to be more time for the copper to react, so more copper will react. Also, we know that powder has got a larger surface area, and therefore there's more room for reactions to take place, and because of that, more copper will react, and therefore your mass increases. Why is it less than expected? So we need to say that copper is not a very active metal. Therefore, this reaction will be less likely to happen and it'll be slower. That would mean you would need more time for this to react. Also, some of the copper or the copper oxide could be lost during the practical. Not all the copper is going to react. We'll just maybe get the surface reacting, so the layers below that won't react. If we don't heat it for long enough, so we might have to heat it for longer to encourage it to react. Or we could even have a situation where the Bunsen burner is not hot enough to help that reaction take place. They're the bullet points that should be appearing in your response. I've counted there that there's 18 of them. So you can use this little mark grid. So for example, if you got over 16 of those points, you can give yourself 6 marks for this particular question.